Hey everyone, and welcome. If you've ever wanted to hook up user actions on a web page directly to your Java backend using the WebForm framework, then you're in the perfect spot. Today, we are going deep on one of its most powerful features, the event attribute. So here's what we're going to cover. We'll start with what these things actually are. Then we'll break down the 4 core pieces that make them work. We'll trace the data from the browser to the server and back, look at some real code, and then we'll get into the cool stuff, handling asynchronous events. You're going to have this down cold by the end. All right, first things first. Before we can start building all this cool interactive stuff, we got to understand the foundation. So what exactly is an event attribute in the wffweb universe?
At its core, it's actually pretty simple. Just think about any standard HTML attribute that reacts to something a user does, like onClick or onChange. Well, in wffweb, these attributes are totally supercharged. They act as this crucial bridge that lets a simple click in a browser trigger some serious Java logic on your server.
Okay, let's get to the heart of it all. The real magic behind any wffweb event attribute is understanding the 4 arguments you pass into its constructor. This is basically the DNA of interactivity in the framework, and it's designed this way for a really good reason. It keeps your client-side display logic cleanly separated from your server-side business logic, which is huge for security and just keeping things sane.
These 4 pieces, they work together like a well-oiled machine. You've got 3 JavaScript functions that run on the client side, in the browser. And then you have one powerful Java method that does the heavy lifting on the server. Let's break down what each one does.
First up is the JS pre-function body. I like to think of this one as the gatekeeper. It's a little bit of JavaScript that runs the very instant a user triggers an event. Its only job is to decide, should we even proceed? If this function returns true, the gates swing open. If it returns false, everything just stops right there. It's absolutely perfect for quick client-side validation. So once the gatekeeper says, "You shall pass," the JS filter function body jumps into action. This is your data courier. Its whole mission is to run around the web page, grab any info you need, maybe the value from an input box or the ID of an element, and bundle it all up into a nice JavaScript object ready to be sent to the server. And now we make the jump to the server method. This is the brain of the whole operation. This is your Java code. It takes that data package from the courier and does all the serious work, hitting the database, running calculations, all your core business logic. Once it's done thinking, it preps a result to send back. And finally, the journey ends right back where it started, on the client side, with the JS post function body. Think of this as the town crier. It gets the result from the server's brain and announces it to the user. Maybe by popping up a success message, updating part of the page, or even sending the user somewhere new.
Okay, so we've met all the key players. Now let's put it all together. Let's see how the data actually makes the trip from a user's click all the way to the server and all the way back again. It's a really clean, predictable sequence.
So it all kicks off when the user clicks a button. Instantly, the gatekeeper, our JS pre-function body, runs its check. If it says yes, the courier, JS filter function body, grabs the data. That data then zips across the network to the brain, your Java server method. The server chews on it, spits out a result, and that result is finally handed to the town crier, JS post function body, to update what the user sees. It's simple, it's elegant, and it's incredibly powerful.
All right, theory is great and all, but nothing beats seeing the real code. So let's get our hands dirty and see how these 4 arguments actually look when we build an onClick attribute.
First, we'll define our server-side logic, the brain. As you can see, we create a server method. Inside of it, it grabs the data from the client using event data. Then, it does its thing, whatever business logic you need, and creates a new wffweb object. That's just the framework's way of creating a flexible data container to pass info back to the browser. And then it just returns it. And now, here's the beautiful part. This is where it all comes together. We create a new onClick attribute, and we just pass in our 4 pieces. But pay really close attention to the order here. First, the JS pre-function body, our gatekeeper. Second, the server method, the brain. Then, the JS filter function body, the courier. And finally, the JS post function body, our town crier. This one line of code creates a complete, 2-way interactive event handler. How cool is that? But what happens when life gets complicated? The real world isn't always so neat and tidy. Sometimes your code on the client side just needs to wait for something before it can even think about talking to the server. Let's check out how wffweb handles that curveball.
So just imagine this scenario. A user clicks a button to get notifications. The browser has to pop up that little dialog box and just wait. The user has to click Allow or Block. Our normal gatekeeper approach of return true just won't work here because we don't have an answer right away. So what's the solution?
Well, the framework gives us a really elegant way out. It's called the action object. This is a special little object that's available to you right inside your JS prefunction body. So here's the key. Instead of returning true right away, you can call action.perform whenever you're ready. This totally decouples that initial click from the actual server request. It's a game changer.
And this code shows it perfectly. See how we immediately return false? That stops the normal, synchronous flow in its tracks. Then we ask for the notification permission. The .then part of that code, that only runs after the user has made a choice. And it's right inside there that we finally call action.perform. This kicks off the rest of the process, but only when the time is right. It's just brilliant.
All right, so let's do a super quick recap. Event attributes are your bridge from client events to server logic. They're always built with those 4 key arguments: the prefunction, the filter function, the server method, and the post function. That creates a really clean 4-step journey for your data. And for those tricky advanced cases, the action object is your best friend for handling anything asynchronous. And there you have it, the wffweb event attribute, completely deconstructed. It is an incredibly powerful pattern for building some seriously robust and interactive web apps. So the real question is, now that you see how this all works, especially with the async stuff, what kind of awesome complex interactions are you going to build in your next project? Thanks for tuning in.